Lesson 6.5. Today we're going to cover the properties of logarithms, the essential questions. How are properties of logarithms used to simplify expressions and solve logarithmic equations? So we're going to apply the concept of the properties that we learned from the previous sections to apply here to help us work with the logarithm functions. And first, I would like to go over the vocabulary. What's the vocabulary for these sections? It's going to be one simple one, which is change your base. In the old days, this formula is very powerful because all the calculators that you come with only has base 10 and the natural number e, which we talked in the previous section as well, the 2.718 natural numbers. But nowadays, with the TI calculators becoming more and more powerful, this change of base formulas has become less and less important. But personally, I think it's a very good idea for you to learn it. It's the essential definition of logarithms, so you will see that it's being applied several times. And just in case, if you don't have a powerful calculator with you, you can always use base 10 or natural log numbers to help you do the problems. So what does it mean by change of base? So I write down the formula first. And notice that what I write here. Do you see that the log base b of m, what did I do to change it into any base? So a is any base. So you can change it into base 10. You can change it to natural numbers. So depending on your applications, your personal preference, you can change it to any base you want. And I'll try to explain it more later. Okay? So let's take a look at some examples here. First one, we're going to expand. What does it mean by expand? So you are given one simple expressions and you are going to make it longer expressions. And if you ask me why would I want to do that? Well, sometimes it's beneficial for you to expand the expressions for you to evaluate. So just to give you like a shortcut hint here. Whenever you see the multiplications, you're going to transfer that into additions. When you see divisions, you're going to transfer that into subtractions. And when you see the powers, you think about multiplications. So what do you see here? Do you see that a squared times b to the 7th power? So do you see that's the multiplications? Multiplications. So what do I do here? I'm going to expand it, make it more than one term here. Multiplications, think of additions. Multiplications, think of additions. And then do you see the power? Do you see the power? We don't stop here. So power becomes multiplications. So this is a two-step process here. So our final answer, instead of the single term, do you see that? The single term, we expand it into two-term representations. And when we use the equal sign, it means exactly the same. So this one is exactly the same as the given expression there. Second one, we're going to take a look at natural log. Again, this is pronounced as natural log. So don't just say ln. If you keep saying ln, you'll forget it. And you will get into the habit of, you forget it in a while. So just say it, natural log. What's natural log? 25 over 3. Natural log 25 over 3. So because it's a division, think of subtractions. Think of subtractions. And that's it. And I'm going to leave my answer just like that. And of course, you can use your calculator to see if you get the exact same result. So if you enter natural log 25 over 3, natural log 25 over 3, what do you get? You get 2.12. And if you use natural log 25 minus natural log 3, what do you get? You get exact same numbers. So I'm just using this to demonstrate it to you that you will get exact same numbers. They're the same thing. So if you can do expansions, what do you think our next example is going to be? Condense, right? If you can make one term and split it into multiple terms, can you go back from multiple terms and then condense it to one terms? So then this time you will have to think the other way, okay? So first one, I have 4 log 4 of m plus 3 log 4 of n minus log 4 of p. So do you see that there are multiple terms? I want to condense into one term. So how do I do that? How do I do that? Do you see a multiplication? Multiplications. So what do I do first? I'm going to put this backwards. And because this only applies to the same base, if you were given a different base, if this was 4, if this was 2, if this was 3, I won't be able to do it. Only because they have the same base, so I can carry this out. Okay, so first thing, I put this back. I apologize, I forgot to put the 3 back. So 4 is being put back, 3 is being put back as the powers. And what's next? So do you see additions here? Subtractions. Additions, I think of multiplications. Additions becomes multiplications. Subtractions becomes divisions. Subtractions become divisions. So that's our answer for this example. Next is with natural log again. Natural log. So as you can see in my lesson, I'm trying to remind you, ln stands for natural log. Natural log. It is a base e. Natural log. So this one I'll do the same thing as my previous example. I'll bring back the multiplication as the exponent. I'll bring back the multiplication as the exponent. Multiplication as the exponent. Multiplication as the exponent. And then because it's a division, so what do? I'm going to write it as 2 to the third power over 5 to the second power. So if you ask me, is it the same thing as I write it as natural log 8 over 25? Definitely they are the same, but we are not practicing about 2 to the third power, 5 to the second power here. So you can leave your answer just like that. Next we have change of base. So do you remember our vocab, change of base? So in case if you forgot, I'll write it down here again, the formulas, okay? You can copy it from your notes, but you don't really have to do it here. I'm just copying down again so that you can see it right next to you. So what's the example? If I'm asking you to do log base 2 of 3. Do you remember I asked you to practice several times to read it out? Log base 2 of 3. What base am I going to change it to? Because of the calculators, depending on what kind of calculators you have, normally you will only equip with base 10. But for this one, I'm going to try to do log base 10 of 3 over log base 10 of 2. And do you remember I said when it's base 10, we don't really write the 10. So I'm just going to write it as log 3 and then log 2. log of 3, and then log of 2. So what if I want to try the same questions with different base? Can I use the natural log? Natural log? Of course you can. And just to show you, do you get the same result on the calculators? Would you get the same result? Okay, because of the change of base formula. So let's try first one. Log 3 over log 2. Log 3 over 2. Log 3 over log 2. So this is 1.58. How about the natural log? Natural log 3 over natural log 2. You get the exact same numbers. And notice, this is very different than log 3 over 2. It is completely different. So please be aware, log 3 over log 2. Make sure you close your parentheses on the correct calculators. It is very, very different than log 3 divided by 2, okay? So make sure you can follow the order of operation. Do you see that there's the parentheses? So the calculator will calculate 3 divided by 2. You're actually just calculating log 1.5. Log 1.5 there. So would you do something like this? You can choose any base to evaluate the questions, but I don't see any advantage if you choose other base than 10 or natural log number here. But you will get the exact same numbers. If you know how to use your calculator to evaluate, you will get the exact same numbers. And that's the lesson for 6.5.